Good morning, everyone. Thanks for joining. We're going to wait for a couple of minutes before we start so that a few people can still join. There's still a few more people coming in, so we can wait another minute and then we get started. Okay, I think by now probably most people will have joined, so we're going to start with our webinar. So thanks everyone for joining. We're very excited that you could make it to this CIENS Frokost webinar. My name is Max, and here with us today is Megan Noel from NINA and Yuri Kasahara from NIBR. Myself, I'm from NINA. And we have on our schedule today first to introduce a new network that's organized under the CIENS umbrella, the CIENS Artificial Intelligence Network, or CAIN. So we're going to talk about our new network a little bit, talk about what the purpose of this network is, the activities that we have planned, and then we are going to talk about a specific topic where artificial intelligence and machine learning is quite relevant, and that is knowledge synthesis. So I'll take half an hour to talk about this topic, and then we will have about 15 minutes for a discussion. Just a few organizing things. Your cameras and microphones are switched off at the moment. Sorry, that the meeting can run smoothly, but we will switch off on your microphone and cameras for the Q&A session in the last 15 minutes. But you can use the chat function at any time to ask any questions, and we do our best to answer these questions in the Q&A sessions. And just for your information, the meeting will be recorded and we will make it accessible after this meeting. And with this, I will hand over the word to Yuri, who will say a few words about the intelligence network and what we are planning to do this year.
Thank you, Max. Well, so thank you everybody for coming. It's very good to see that a lot of people enrolled for our first webinar. But just a few words about CAIN. CIENS is the CIENS Artificial Intelligence Network. It was created this spring by members interested in exchanging knowledge and expertise about how to apply recent developments in machine learning and data science to their own research, and also exchange these experiences. Because we realized that a lot of us in the different CIENS institutes were working or interested in work with this type of methods, and we thought that create a network within CIENS connecting us would be very useful. And I think the fact that there are so many people enrolled for today, it's a positive sign of this interest. So CIEN has a steering committee. It's composed by me, Yuri Kasahara from NIBR, Megan Noel from NIVA, and Max Naurat from NINA. And the way we tend to work is to promote seminars like this one, with members presenting their own experiences, but also presentations from external speakers who bring their own knowledge and expertise to share with us. Also, some workshops where actually will be more sort of hands-on, like with some more coding. And also some more relaxed social events, somehow connecting artificial intelligence to a more social, relaxed but also as a network, we count on the inputs from all of you to make this thing real. So if you have any suggestion, work to present, interesting presenter to suggest, please contact us. We're also going to make available in the chat a link for the survey asking about topics of interest to next seminars, workshops, presenters. So please help us make this network useful for you all also. With that said, I give the word to Max. So he's going to present his own experience with automated literature review. The floor is yours, Max.
Thanks, Yuri, for the introduction of our new network. Megan popped the link to our survey into the chat. So if you have the time, it'd be great if you could respond to this and help us developing our network further, following your own interests. And if you want to be involved and keep in touch with us or get updates from us, you can add your email address in that survey, and we will keep in touch with you through with updates. And with that,
Max, if I may add something quickly, just while you're talking, I'm sure people might have questions pop into their minds, and they can put them in the question and answer section or wait until the end to ask them.
Perfect, thank you. And today's webinar topic is on knowledge synthesis and how we can use artificial intelligence and machine learning approaches to improve this process, or at least make it faster. So I'm an environmental social scientist, and I'm working a lot with knowledge synthesis. So I thought this is a really important topic to talk about if we think about AI and machine-based and machine learning. But why are knowledge synthesis actually important? So I wanted to first take a step back and think about why these are important. And they are important, first of all, because by looking at many different studies on a specific research topic, it's much easier to spot errors or bias in individual studies. So we can, by looking at many different studies, reduce that impact of bias and errors. Knowledge synthesis is also important to identify gaps in the evidence. By looking at many different studies on a topic, we can see what we do know, but also what we do not know. And with that, we can sort of pave the way for new empirical research and where we want to spend our resources the most effectively. But combining findings from individual studies in synthesis can also create new findings that haven't been known through individual studies before. And syntheses often facilitate decision making because they are higher level evidence than individual studies. So evidence from systematic reviews or meta-analyses, for example, is very useful for decision making processes. And they're also really useful for practitioners who aren't maybe necessarily researchers themselves. Practitioners may not be able to read individual studies, and for them, synthesis of the state of the knowledge are quite important as well. So in addition to that, science is accelerating, and the world's scientific output is increasing really rapidly at the moment. So it's doubling about every 9 years, and independent from the discipline we work in, we really can't read every relevant paper anymore. And that means that also we as researchers, we increasingly rely on knowledge synthesis to stay on top of our fields. The problem is that traditional knowledge synthesis, they're really quite time consuming to do. And because of that, they're also expensive. There's some empirical research that looked into how long it usually on average takes to carry out a systematic review. And that study found that on average, a systematic review takes about 13 months to complete, and that's often for multiple people. So it's very time consuming to do these types of reviews. And because scientific progress and output is so fast at the moment, there are estimates that suggest that many reviews, a quarter of reviews, are already outdated 2 years after publication. And this knowledge synthesis is really a crucial basis for decision-making processes, and the demand for from policymakers for knowledge synthesis is kind of faster than reviewers can supply knowledge synthesis. So scientific progress is in a way outpacing our ability to create reviews that are then used by policymakers, and that's been coined the synthesis gap. So we're just not quick enough to review the science we do to make it accessible to policymakers, and that's a problem. Now we have new methods developing quite rapidly in the field of artificial intelligence and machine learning. Some of these are text mining or natural language processing. That's the large language models like ChatGPT and other alternatives that we all know by now, different machine learning approaches. And the rapid development in these fields is sort of promising, as these methods may be able to speed up the speed of which we can carry out knowledge synthesis. So, for example, they can help us decrease the time we need for reviews, and by that they can reduce the costs of knowledge synthesis. That means that there is more time for researchers to focus on tasks that computers cannot perform. And there's also a quality dimension. Using AI and machine learning supported knowledge synthesis can mean that there is less variability between reviews, because automating the process means there's less variability, because humans tend to make decisions a bit more arbitrarily than machines. Before we start looking into the specific steps of knowledge synthesis and where we can use AI and machine learning approaches, I want to stop and think a little bit about what artificial intelligence actually is, because we talk about it in our daily lives all the time now, but it's actually not very clear what it is. And there isn't really a universally agreed definition of artificial intelligence either. So different people mean different things with it. But for example, if we look at Norway, Norway defined AI in their national strategy for artificial intelligence as systems that perform actions physically or digitally that are based on interpreting and processing structured or unstructured data to achieve a given goal. That's really quite broad, and it contains many different strands of techniques. So there are three main components or fields within what we traditionally talk about artificial intelligence. And that includes robotics. That's if we think about self-driving cars or our vacuum cleaners at home or lawnmowers, that's not necessarily so relevant to knowledge synthesis. We have the field of machine reasoning, which is sort of a software process that uses rules and various areas of logic to make inferences. And we know that often from large language models like ChatGPT, because machine reasoning is used to understand meaning in human language. That can, to some limited extent, be relevant to knowledge synthesis. But then the last area within AI, and that is what we usually refer to when we talk about AI, that's different machine learning approaches. And there we have supervised and unsupervised machine learning, deep learning, reinforced learning, and natural language processing, which is sort of the basis for our large language models and ChatGPT and so on. And that's probably the most relevant area of artificial intelligence if we think about knowledge synthesis. Now, let's have a look at the different stages in knowledge synthesis and how we can use AI and machine learning to support these different stages of knowledge synthesis. And AI and machine learning are useful to varying extents in these different stages. So if we look at the first stage, which usually involves defining a research question, so deciding what's the problem that we focus on and that we want to review the existing evidence on. That's traditionally a task that's a task that's performed best by humans because it's in our interest to decide what we want to find out. So AI and machine learning techniques are not that useful for that stage of research at the moment. The second stage usually involves developing a protocol, so defining the scope of knowledge synthesis. What are the inclusion or exclusion criteria for the relevant literature? So what do we include? What do we exclude? You have to decide on the method for how to collate the data, how to appraise the quality, and how you want to go about analyzing the data. That can be qualitatively or quantitatively. So these are also decisions that are best made by humans because these are just defining the scope of the review and how you will go about analyzing the data. So AI and machine learning become more relevant in stages 3 and 4 of a knowledge synthesis. The third stage does usually involve selecting relevant literature, and that starts with developing a search strategy, and it involves carrying out a systematic literature search on different databases. And in the last step, analyzing the data and then synthesizing the data, I'll talk a bit more about how AI and machine learning-based methods can be used for this. Okay, let's have a look at developing a search strategy. So developing a search strategy usually involves identifying relevant keywords that align with your research question and your protocol. And it's an iterative process to balance both sensitivity and precision. Sensitivity means you want to include as many high-quality studies that meet the inclusion criteria as possible. But the precision is also important, and that means you will want to limit the total number of studies to screen, which can often be many hundreds or thousands of studies. So you will want to be precise in your search string. And that's usually quite time-consuming process with involving trial and error. And here, large language models, the ones that most of us know, like ChatGPT or Gemini or Copilot, can help us to create effective search strings for specific databases. And that is because when we develop search strings, we have to usually identify relevant synonyms and truncations, different spelling variations of words, American and British English, and we have to consider all these different things. Doing this manually is really time consuming, and large language models can do that reasonably well. There's also some empirical evidence that tested, for example, ChatGPT, if they tested the performance of ChatGPT in creating search strings that are both sensitive and precise, and it's been doing reasonably well compared to humans. So this is an area where we can use AI-based methods to save some time. This may save time, but it doesn't necessarily improve the quality of these search strings. And we always have to consider that we don't know what's happening in the algorithm of these models. But because we manually review search strategies developed with the help of ChatGPT, for example, it's sort of still transparent how you got to develop this search string. So it can be quite useful for that stage of knowledge synthesis. Now, let's look at the next step of knowledge synthesis. Now we have developed our search string, and we have searched our scientific databases. We have downloaded the articles to our software or hard drive, and now it's time to decide which papers, which articles to include and which to exclude. And that's usually done in two stages. First, you screen the titles and abstracts of articles. Before then, in a second step, you screen the full texts. Often that's in addition, that's done by multiple reviewers to reduce bias. So this really is a quite time-consuming step in any knowledge synthesis. And there are some automation techniques available that can help us save some time with this. So, for example, the many available softwares now contain a machine learning component based on supervised machine learning that learns from review decisions. So you start your title and abstract screening manually, include papers, exclude papers, and the machine learning component of the software learns from your decision, and based on this learning, ranks the remaining articles as relevant or not relevant. So the remaining articles are organized in two batches, sort of, and one batch is clearly irrelevant articles, and the other batch is articles that are very likely to meet the inclusion criteria. And that makes it much easier to exclude a large amount of papers rather quickly. And there is some empirical evidence that tested these sort of machine learning approaches, and these studies find that there are quite substantial time savings through using this. One study reported that this can reduce the time spent on screening by 60 to 90%, even though I think maybe this is a quite high figure. There are many different softwares already available right now to do this. In Niva, we use HubMeta quite a bit, which is a freeware, which is still a bit buggy, but it can be quite useful and integrates many different steps of knowledge synthesis. But there are many alternatives to choose from. For example, there's also Rajan using a quite similar approach, and AS Review out of Utrecht University using a similar approach. Once all the data are screened, we went through all the different studies, excluded some, included some. We have a final set of papers that meet the inclusion criteria, and it's time to extract data from these remaining studies. And that's a really time-consuming process. And traditionally, you open a PDF and you have an Excel sheet alongside that with a few data variables that you want to extract. Often that focuses on things like authors, study location, study population, sample size, methods, and so on. And then you have to go through this PDF and extract all this relevant information manually and add it to an Excel sheet. So really time consuming. And we do now have some text mining approaches that can automate this data extraction process, at least to some extent. For example, there is a software called Laser AI. It's a paid software that integrates many stages of carrying out a systematic review or meta-analysis, similar to many other softwares. But what is outstanding about this particular software is that it can automate data extraction to some extent. So it can automatically extract predefined data variables from individual articles. And the good thing here is that there is a validation process involved. It means that the human reviewer has to review each of these data extraction decisions made by the software, so you can validate the decisions made. And generally, with this data extraction automation approaches, the general rule is the more standardized the terminology in a specific field, so for example, the health sciences, the better these perform. So things like sample size or study location or study population, that's relatively easy for a text mining approach to extract, but when concepts get more complicated, then it's performing less well. There are many different tools available already that have a functionality like this. For example, the API reviewer coming from the health sciences integrates a software called the Robot Reviewer, and that software also uses a text mining approach and assesses the risk of bias in individual studies, which is commonly done in trials, in medical trials. You assess study quality, and that can be done automated with this Robot Reviewer software, and it's been empirically tested how well this is performing comparing to humans, and it's been shown that it's on a similar level of quality. So these things perform reasonably well, and there is usually a mechanism integrated to validate the machine made decisions. The last stage of knowledge synthesis, data are analyzed and synthesized. There are different ways of going about this, but in some cases, you will want to do a content analysis, and that's traditionally done manually with coding qualitative data. But now there are some softwares available that can, at least in some part, automate that process. There's, for example, the well-known qualitative data analysis software called NVivo, which has an auto-coding wizard integrated that uses a supervised machine learning component where the reviewer has to do some manual coding first to establish some codes, and then the machine learning component can auto-code the data set to some extent. Our studio has a similar package for automated content analysis. These the quality of these automated approaches here is varying. Again, the easier the concepts, the easier it is for machine learning components to extract data, and the more complex concepts get, the more difficult it gets, and the less the quality of these processes is. It's really important to say that these kind of tools have to be used with care, and expert knowledge is still required with all these processes. So using some of these AI and machine learning based tools can definitely help us save some time, and by that some cost, or at least free up time for doing other things that computers can't do. But there are also some risks involved with this. And these are mainly along 3 lines, and that's transparency issues, reproducibility issues, and the risk of bias. So transparency is an issue if we use AI-based methods where we don't understand the underlying processes for making decisions. That's the case with things for like ChatGPT. We don't really know the algorithm behind it, so we don't have any transparency to understand how decisions are being made. And that's a problem if we want to do research. And a lack of transparency often means issues with reproducibility, which is another a key component of high quality research. If we don't know how decisions are being made, we can't reproduce this research, and that's problematic. So it's really important to think about these 2 aspects. And then using AI and machine learning can also lead to some specific biases. For example, data or findings can be overestimated more easily. Sometimes predictions that are automated are inaccurate or unfair. Sometimes specific information gets excluded. And there's also the issue of bias towards underrepresented or marginalized group that is kind of amplifying bias and discrimination that we have in our world already. So these are issues to look out for. So there are many new tools coming out at the moment. They're developing fast. There are many different alternatives to choose from for different and distinct steps in knowledge synthesis. It's really important to emphasize on many of these tools can be usefully and ethically applied. It's really important not to use them uncritically because that can introduce bias in any knowledge synthesis, and that's the very thing that we want to avoid with using a systematic and structured approach in understanding a specific body of knowledge. And care is specifically important for tools where we can't understand the underlying processes. So we can't ensure that what the tool is doing is reproducible, and that we have to be very careful how and if to use such a tool. And really important to know, it's really important not to just blindly trust any output of any AI or machine learning based tool. It's also quite important to consider what type of tool to use. That's an important decision to make. It's not an easy one either because there are so many different tools and there isn't always a lot of information about them available. But maybe 2 things to think about when you consider a tool for your own knowledge synthesis, and that's what type of knowledge synthesis are you going for? Is it a scoping review? Is it a systematic review or a meta-analysis or even something else? There are different tools available for different types of knowledge synthesis, so it makes sense to choose something that fits your type of synthesis. The discipline also makes a difference. So I'm from the environmental sciences, and most of the knowledge synthesis tools aren't developed for the environmental sciences, but come from the health sciences, which are, well, leading the way in knowledge synthesis. So in the environmental sciences, we are kind of adopting many of the tools developed in health sciences, but sometimes that isn't so smooth because we use different concepts. So discipline is an important consideration as well. So these new technologies, they're here to stay. They would change the way we do knowledge synthesis. And in part, that's definitely a good thing. There are many advantages to it. We can save some time. We can save some cost through this. We can open up time for things that computers can't do. But it's also important to consider that these methods, they can't replace at all expert knowledge and knowledge about the methods that we're applying. They can just be used as tools to speed up some of these processes. And it's really important to also always consider the risks that are involved in creating bias, and that has implications for equity if machine learning approaches amplify some of the inequalities that we already have. And we always have to ensure that the tools we use are reproducible and transparent, so that we understand the underlying processes used in these tools. And that's something that NIFU also is emphasizing on. They recently published a report emphasizing on that it's really important to use AI and machine learning based tools critically. But if we do that, then they can also make our life easier. And we'll see many changes in the future where these approaches will be integrated in our knowledge synthesis processes more than now. Okay, thank you. That was my presentation. And now we can open up for questions. I will just open up the microphone and camera. So you can now switch on your microphone and camera if you do have any questions.
I see that Auden has a question so far.
Yeah. So sorry, Megan, I just pushed the wrong button. I just want to clap hands. So sorry.
No problem. I see we're still waiting for some questions to come in, but maybe I can kick us off with one, Max. I'm wondering, when it comes to understanding how well these things are performing, do you have any advice on how we can kind of validate how well the AI is doing in terms of synthesis?
I think I would recommend if you decide for a specific tool to check if there's any empirical research testing this. So for example, if we think about using ChatGPT for creating search strings, there are studies published that just tested ChatGPT compared to the human performance. And that means there's some evidence to suggest that you can use this in an ethical way. And you won't find these type of empirical studies for many types of reviews. So in that case, it's important to really try understanding that tool. And if you're not able to, and you don't find any literature on it, then maybe talk to a colleague who has a better capacity to understand the tool. But if it's not possible to understand the underlying processes at all, then it might be a good idea to stay away from that tool in the case you carry out something like a systematic review. For scoping type of things, for getting an initial idea of what to look at in your study, you don't necessarily need to understand the underlying processes to the same extent, I would say.
Thank you. I see we have a question here from Hedda. She asks, what do you think about Elicit, Insightful, and Notebook LM?
Oh yeah, thanks for that question. I'm only familiar with Elicit, and I think this can be a really useful tool for sort of an initial scoping of a specific research topic. So if one isn't super familiar with a specific topic, using Elicit can be really useful to get an initial idea of what's out there. So it can be really useful, but for high quality systematic knowledge synthesis, this does lack the transparency of the systematic process. but it's really useful for getting an initial idea of what's available, I would say.
Thanks. Our next question is from Asbjørn.
Yeah, thanks for a very interesting presentation. I wonder, would it be a good idea for this network to make a kind of list or mapping of different tools at different stages? You mentioned different disciplines and what your research is focusing on. But for many of us, I suppose, this is a rather new field, and also it's a very dynamic field. So would it be useful really to make a list, maybe with some indications of what this tool is best applied to? Thanks.
Yeah, I think this is an excellent suggestion. It would be very useful to have something like this. So I think we can have a chat about this internally. Perhaps we can create a website with a list of things that is continuously updated. But for that, it might also be useful to get feedback from the public. But yeah, generally, it's a very good idea. So thank you for that suggestion.
All right, we'll go over to Yuri.
Yeah, no, actually, thank you, Max. I think actually related to Megan's first question about the validation, I wonder if, especially in the screening part, where you're actually using the sort of model to identify relevant text or use of the concept that you're interested in, do these sort of softwares that you are using, do they have like a sort of validation or like measures of accuracy, efficacy, precision? Or if not, do you think it'd be useful actually, especially in the screening phase, for the researchers to show actually these measures, like test themselves how precise or how accurate the model is in screening the papers that you selected in the previous stage?
Yeah, that's a really interesting question. And usually in a systematic review, you in the screening process, you do this by 2 or more researchers independently, and then you compare screening decisions to assess inter-rater reliability, and then you develop a metric. You calculate a metric called Cohen's kappa, which is, I don't actually know what it calculates, but it's a metric that assesses how similar the reviewing decisions are, and then it rates this in different categories. And there's a general suggestion if the rater agreement is over a specific threshold, this is seen as reliable enough to go ahead with your review. Now, there are some studies that have tested this empirically using machine learning approaches as like a second reviewer or a third reviewer, while there is still a human reviewer in the group. And these studies usually find that inter-rater reliability with having a machine learning component involved is about the same level as another human. So, well, there's some evidence to indicate that there we can use machine learning components. But in individual studies, we don't have the capacity to test this. So we just have to rely on other studies when we use machine learning components as to support the screening process, if that answers the question.
Max, we have another question here in the chat we actually have 2, one from Christian. He said, the reasoning path in many models is hard to reproduce. What challenges do you see connected with true reproducibility? Thinking about large knowledge databases, for instance.
I'm not really an expert on reproducibility, and I'm not sure what Christian means with large knowledge databases. The databases I can think of that we usually use are Web of Science or Scopus, and there there aren't any machine learning approaches to extract data from them as to yet. So there I don't see any issues with reproducibility. I don't know if you have other perspectives on this.
Yeah, I don't see him putting his hand up. So I guess one of the things that comes to mind when I read this question is that oftentimes with something like a large language model, if you ask the same question twice, you would end up getting 2 different answers, right? So perhaps this is what he's thinking.
Yeah, and in that case, we can't really ensure reproducibility at all.
Okay, I see we have one more question in the chat, and then we'll go over to Ben, who's also raised his hand. So Manuel says, I have heard the idea that knowledge synthesis through AI can have an effect on the advantages of free market systems compared to authoritative systems. The underlying assumption is that free market systems allow for the distributed computing across many actors in society of very complex problems. This is argued to give free market systems an edge on authoritative systems, since the latter's centralized computing cannot cope with the complexities of the issue. However, with AI, very effective centralized computing may slowly become as, if not more, powerful than distributed computing. What do you think about this idea?
That's a very interesting comment. I think it's more of a comment than a question. I think that there might be some truth in that, but I'm using AI and machine-based learning approaches in a very focused knowledge synthesis type of way. So I'm not sure about the effects on large political systems, I have to say. But it's definitely an interesting comment.
Okay. I saw that Ben had his hand raised for a moment, but he's taken it down. So maybe that's
it's mainly a comment about the reproducibility actually. So it's actually possible to make the model reproduce the results because it's just like it's basically a set of mathematical operations, and so it's possible to fix a random seed so that the like everything goes exactly the same. So it's like if you don't place a random seed, the model will like produce a different answer every time, but it's possible to make the model reproduce the answer in a way. So like that's some strategies to reduce variability in the responses. Just like side comment.
Thank you. That's really useful.
Yeah. Great. So we don't have any more questions at the moment, but I would like to encourage people to maybe click on that link that I shared in the chat for the survey. And basically what we're asking for is suggestions of what you would like to hear from these seminars. And also in terms of the events that we organize, if you have some fun ideas, we had a suggestion to maybe have a competition. Thanks, Arden. You are off mute. So would you like to ask a question?
Yeah. I mean, in lack of all the questions, I just have a brief one. Coming back to Mac's reference to the NIFU report, could you just elaborate a little bit more on the actual concerns and the cautiousness of not taking it too easily when you apply AI?
Sure. I think most of that I've already mentioned during my presentation. I'm not too familiar with the content of the report, but it warns about the uncritical use of methods and that we should make sure to familiarize ourselves with the underlying processes within tools that we want to apply. I think it's sort of the summary of what that report, the headline of the report.
Great. Well, we are actually finished ahead of schedule. Yeah, do feel free to contact us if you'd like to know more about this.
And stay tuned for the next webinar that's going to be happening after the summer. which we will publish on the CIENS website. So yeah, thanks everyone for joining, and I hope to see you after the summer for the next seminar. Thanks everyone.
Thank you.
All right.
I think you can stop recording now.
Yes. Oh. Start recording. Not quite sure how to do this. I'll have to figure this out. Teams.
There's no button on.
It's live, but in the meeting settings, I set to automatically recording, but now that it says start recording, so is this recorded? I hope so. Well, if not, then well, we don't.
I'm probably gonna have like a very large file downloaded to your computer.
It's kind of annoying that I can't make you co-organize this because you're not NIVA. So you would have all the rights then, which would be making things much easier. But yeah, thanks a lot for your.
No, it was good. Oh, it was quite a lot of people. I think the highest was like about 85 or something.
Yeah,
that's not bad.
Yeah. We've got one more participant here.
Someone coming late. Because there's a.
I knew I was a little.
That's good. I think we just have a. I wonder if, like I said, maybe we should contact Alden or like now Shell to ask about how we do with the video. If there's any platform or way to upload this, but also like I don't know, the PowerPoint. I think we can also put the presentation available.
He anyway sent us an email yesterday. I don't know if you've seen.
Oh yeah, about to present it came to the board.
I can answer to this. Yes, actually that day it's the Forskningsdagene. So I kind of signed up for a few events on exactly that day. So
let me see.
I can talk to the people I'm doing this with if I need to be there in exactly these 2 hours. I kind of just blocked out the whole day. But how does it look for you?
Oh, September I don't have I'm just away in the beginning, like from the 4th to the 8th, because I'm going for a conference. But 19th I should be here. Like if you're not available, I can go also with Megan, because they said that also could be via Teams.
Yeah.
So I mean, I don't think they want like a big thing, like just like a short introduction and with the plan, and hopefully, we just have to see actually when are we going to have our second webinar, right? Because it could be around. I think we should be around the end of September, maybe.
Yeah. Not the last week if possible. That's school holidays.
Oh yeah, is already the
last week of. Yeah, well, I think it's like the
last. It's not the 1st of October.
It is the first week, but the first. It actually starts in September already.
Oh yeah, okay. I haven't seen the.
Oh no, I lie. Sorry, it starts on the 28th of September, which is a Saturday.
Okay.
Okay. Yeah.
But you are in Oslo also, or you're in another city?
No, I work in Oslo. I live in Ås, but I do come
Yeah,
through
but
to Oslo
us
every day.
follow the same calendar as Oslo, right?
Yeah, I think for this kind of thing,
okay.
yeah.
Because in some parts of the country, Høstferie is in another week, so it's
yeah.
they don't coordinate nationally for this.
Yeah, that was a little bit funny with Alden, like at the end there. So this little dragging on.
That happens.
Oh my gosh.
Happens all the time in meetings.
Normally muted though.
It's good that they were muted during the presentations.
Mm-hmm.
Yeah.
Yeah.
Yeah, we can eventually see if we make actually physical, maybe some of the events also.
It would be nice to physically meet, have some breakfast. But the social event we will definitely have physical, and for that maybe we have to start planning. It's right after the summer.
Yeah. I mean,
things up.
I think a place like Kulturhus, because I think CIENS sometimes they use not sometimes, often they use Kulturhus for these physical events.
Yeah.
They had those where they have this what is that the sort of short pitches about how to save the world or something like this.
Yeah.
With researchers, and then they do often in Kulturhuset.
It's probably doable to find a slot in Kulturhuset, relatively short notice. But if you invite external speakers and stuff like that, it's probably good to have at least 4 or 5 weeks, 6 weeks of time to organize.
Oh yeah, no, for sure.
Yeah.
Yeah, I mean, and for the external we have to see, like, if it's from abroad, maybe it's okay to have a webinar.
Yeah. Yeah. Now we can. I'll answer Shell that at least one of us will join the meeting, the steering committee meeting in September, and we'll see when he sends through the how is he calling it?
Yeah, the board meeting, right?
Yeah, but he's gonna the bevillingsbrev, like and how we can get our hours and stuff. Because now I use internal hours.
I think I don't get it. I didn't get.
You didn't get it?
I haven't.
Yeah, I think you got it. You're on CC. It was yesterday afternoon.
Okay, yes, then
Yesterday.
that's why.
Huh.
Guys, I actually have to jump out. I'm interviewing somebody in 2 minutes.
Yeah, right. Okay. No worries.
Thank
you so much.
We're getting an ML data scientist in my group, so I'm very excited about that.
Oh, nice.
Good luck.
Yeah. Thank you, and well done today. That was really awesome.
Yeah.
Thank you.
Very good.
You kicked us off very well, Max.
Great. Thank you.
Cheers.
Yeah.
I'll see you.
But but we can talk later. Actually, I have to go back to content analysis. I'm
nice.
working with analyzing these NO reports, and then actually I'm testing some like these word embeddings to capture like co-occurrence of words. So
cool. That's exciting. I have to jump to the next presentation, annual meeting of an EU project.
Oh yeah, okay. About what?
Investing in nature-based solutions. So it's kind of an economics project, financing nature-based solutions.
Oh yeah, cool. So are you doing using any AI for this, or like machine learning?
No, it's all manual, traditional research work.
Good.
Most of it.
Yeah. Well, I still do quite a lot of manual also. Like I have to sort of classify, like do some screening because the algorithm is not smart enough yet.
So, yeah, we'll have to wait for many things a little bit longer.
Okay. No, but good work, Max. So
thank you.
We'll keep
thank you
in touch.
for your help. And yes, we'll be in touch.
Yeah. And let us know if you get the answers from the survey, and then if you if you want some help or
I'll be in touch.
Yeah. Okay.
All right. Thank you.
Bye bye. Have a good
Bye.
day.